Hello everyone! Today we're going to talk about an upgraded feature of the Dragon Breath ribbon system in 3ds Max. During actual use, we often encounter this kind of situation. For example, with skirt hems. They are usually built from independent bone chains. When our character performs actions like lifting a leg, and collision happens, it's very difficult to achieve precise collision with those bone chains. Moreover, even if a collision with the bones occurs, the skirt may still not be affected, so overall, the result isn't ideal. That's why we developed a feature based on bone positions to drive the motion. Alright, first, let's open the tool panel and take a look. Basically, all operations are done in this area. All setup and adjustments happen here. Let's first see how to use it. The first step is adding a driving bone. For example, this leg bone here. We want its motion to drive this area, specifically the root bones of these skirt elements. So we add it here. After adding it, we select it. Select it in the list, and then select the root bones that should be affected. Using this button, we add them into the driven list. You can see they're added. When reviewing, single-clicking this and double-clicking selects all the driven bones. Single-click selects the driving bone. Let's add another one as well. Same process. The bones it drives are also added. Alright, now it's added here. We can switch views to inspect it. The plus and minus buttons. If there are extra items we don't need, we can remove them. We won't operate this one now. If you want to add more, just click the plus button. Same on this side. Using the minus button, after removing, it deletes the entire set. Let's demonstrate. Click the minus button, and everything is gone. Now let's add it back. Remember, after making changes, you must select the list so the system knows which item you're editing. The driven bones. Select these small bones and add them here. Alright. After adding them, we need to click this to record the initial pose relationship. The initial pose relationship is best recorded in a T-pose. If there's already interpenetration, then the initial state already has overlap. All calculations are based on this initial relationship, so we need to click this. After clicking, we can save this entire setup. Save it out. For example, I'll save it here. I'll give it a random name and save it here. Once saved, next time when animating, let's say I delete everything. We can directly load it back, including the previously recorded initial pose data. It's all preserved. Alright, now let's create a simple animation. For example, a leg lifting motion. Lift it this high. Then lift it further back. Okay, that's the animation. Now we can use root bone driving to create collisions and perform the calculation. There are two parameters to note here. The first one is smooth. This prevents jitter during collision. Usually, the default value of 3 is sufficient. Alright, next is the weight parameter. What does weight mean? Alright, for example, in the initial state, these two bones are positioned like this. When we lift the leg, the skirt should follow upward. If the value is 1.2, the movement amplitude becomes 1.2 times. If it's 0.8, it would be like this, about 0.8 times the motion. Alright, that's the basic concept. Okay, for example, we can change it to this, like so, then run it with this parameter setup. Let's take a look. Click this, and you'll see it start to work. When it moves forward, it pushes the front bones aside. When moving backward, it pushes the back bones aside as well. But we notice a problem. The middle bones move with too large a ratio. We want the front and back proportions to be correct, and the middle to be smaller. We can limit this using rotation constraints. Apply a rotation limit. Alright, press Ctrl plus Z to undo the previous driving operation. Select the root bone. Select the skirt root bone. Then click Limit Rotation. Alright, after clicking, you can see, in the Modify panel, there is now an angle limit. Okay, we disable Roll here. To avoid jitter, then we directly set it. For example, a maximum rotation of 30 degrees. Alright, let's look at how the effect changes. We can see it only rotates a small amount. This looks much more natural. We also added rotation limits to the upper section. This limits the overall rotation during the entire solve. Feel free to try it out. The result is similar to what we just showed. Alright, now we can proceed with the ribbon simulation. For example, I'll just set it casually to 5. Now we can combine these two features together. Let's take a look. The collision becomes much more accurate. Alright, that's the overview of this feature. Thank you all.